This is a short version of practice problem number 4 from lesson 9, Moves in Parallel, and unit 1, Rigid Transformations and Congruence. In practice problem number 4, there is a rotation of triangle A, B, C around point D. So point D is the center of rotation, and this triangle then is moved from this position, rotated around, and ends up in this position, and renamed triangle A prime, B prime, and C prime. And because this is a rigid transformation, that means that these three angles remain the same size as these three angles here, and each of the side lengths remain the same length as these side lengths here, because it's rigid. It doesn't change. The only thing that's changing is its position within the plane because of the rotation around this point D. So your job is to realize that angle B is the same as angle B prime, and angle C is the same as angle C prime, and length BC is the same as length B prime C prime. So let's go through how you know that. Let's look at the rotation. So you're looking at side length B prime C prime, B prime C prime. What is its length based on this side length right here, BC? Angle B, what's the size of angle B based on the size of angle B prime? And angle C, what's the size of angle C based on the size of angle C prime? This is supposed to be a short video, but I do want you to see that rotation. So the rotation of this triangle around point D ends up here. And I want you to see the size of that rotation. In other words, the number of degrees of that rotation. So how do you figure those things out? We can look at angle A, D, A prime. So this is the number of degrees that point A rotates through the plane to end up at A prime. So it follows this path. This is a circle with the center at point D, and it's going to land here at A prime. And to figure out how many degrees it rotates, you can use a protractor. Just place the protractor at the origin is at point D, goes through 0 for point A, and A rotates around 120 degrees to A prime. If A rotates 120 degrees to A prime, everything else has to rotate 120 degrees. It's a rigid transformation. Everything else has to move in the same way. So B rotates to B prime, and this is its angle of rotation. This is how much it rotates. Follows this path, similar to A. And the size of that angle, once again, has to be the same. It's 120 degrees. And C rotates to C prime. Again, it follows this path, and this angle C, D, C prime has to be the same. It has to be 120 degrees. And it is. Okay, let's look at the rotation of this triangle along these three paths. So A along its path, B along its path, and C along its path. It's going to start rotating. So A is here now, B is right here, and C is right here. And you're going to see that this side length, this is BC right here, it's going to end up right on top of B prime, C prime, like that. And so from this, you can see that B goes to B prime, C goes to C prime, and BC goes to B prime, C prime. So angle B is 52 degrees. That's this angle right here. It's the same angle. Angle C is 50 degrees. That's right here. It is the same angle. And BC is 4 units in this triangle, and has to be the same 4 units for B prime, C primes. So this length has to be those 4 units. And the idea is to get to the point where you can look at this center of rotation and realize that C goes to C prime, B goes to B prime, and A goes to A prime. And again, because it's a rigid transformation, nothing's changing other than its position in the plane. So the angles are the same size, and the side lengths are the same size. They do not change. So these lengths correspond with these lengths.